Hey guys, it's Owen once again here. This is going up on my personal channel, and I'm going to explain another topic that pertains to orthoreology, which is the topic of aiming a marksmanship rifle and the impacts of barrel inclination on shot alignment. To begin, I will discuss something called cohomology theory, which says that the basic topography of the shot will be constructed by the location of the shooter, the location of the target, and the relative locations of the shooter and the target, in terms of the horizontal distance separating the two, and also the vertical distance separating the two. As they show in movies, the sniper will often choose their perch, and the sniper can choose perches that are above the target, at the same level as the target, and they can also choose a perch that is below the target. In position cohomology, there are three basic terms that describe a shot. The sniper can have 1. Climbing fire, where the sniper shoots a target that has a relative vertical position where the target is located above the shooter. 2. Level fire, where the sniper shoots a target and the shooter and the target are at the same vertical level. The shooter and the target have even keel. And 3. Plunging fire, where the sniper is located above the target and the sniper is aiming downwards into a valley or something like this. The direction of the bullet travel is aligned with the direction of gravity. The way that the cohomology exercise will work is that you will plot the location of your target on the map, and you will plot the location of the shooter on the map, and then you will perform the rheological examination as it pertains to the 2 points that you have selected on the map. Other exercises which involve position cohomology include being given the location of your target and choosing the fire position that gives you an excellent chance of landing your shot on the target. Next, if you remember from high school physics class, the shape of the bullet's trajectory is a quadratic curve, where the algebraic expression is translated by downwards acceleration, given in meters per second squared. As predicted, this will form a mathematically uniform curve that represents the curvature of the bullet, and the curvature of the bullet is a topic of study in orthoreology. You should note that the sniper's line of sight is not the same as the bullet's trajectory. The line of sight is a straight line, and the bullet's trajectory is a quadratic curve. Therefore, we have not one but two projective spaces, and both of these projective spaces need to be superimposed onto each other and align with each other in order for the sniper shot to be successful. The bullet comes out of the barrel at a particular angle that is aligned with the reticle on the scope. The sniper will look through the sight picture and compensate an amount away from the reticle. You can interpret this as an orthotic bridge, where the sniper adjusts the bridge so that they have proper orthotic alignment for the shot. The amount by which they adjust the bridge is always negative. The question of interest in orthoreology for marksmanship is how much to adjust the bridge by. So, I want to explain the topography of marksmanship at the next level. The bullet comes out of the barrel and the sniper is looking through the scope. The geometry should be interpreted so that the bullet and the scope are located in the same place, and they will be modeled as a single point. The bullet comes out of the barrel and the sniper is looking through their sight picture at slightly different angles, and this explains the compensation angle. When you actually look through your sight picture, you will estimate the angle of compensation and count how many angle degrees to adjust your bridge for. What this actually forms topographically is an angle, where there are two objects, one curve and one line, coming out of the barrel of your gun. The bullet's trajectory, which is aligned with the reticle, and the sight picture of the target. Your job is to estimate this angle. If you estimate this angle correctly, then this will mean success in the marksmanship operation. So we have this topography where there are quadratic curves and line segments. And now the orthoreologist needs to perform chord drawing exercises onto the quadratic curves. I can take quadratic curves and I can tell you that the angle of correction does not remain uniform with respect to changes in barrel inclination. If you have climbing fire, level fire, or plunging fire, you should respect each of these modes as their own types of fire. The final result of this proof is that the closer your barrel angle is to the horizontal, the more you should compensate. Plunging fire is the most accurate mode of fire, and climbing fire has a few unique properties that should be considered. Level fire should be considered your core training exercise, where the majority of your shots will be taken. Level fire is your baseline. You will be practicing correctly if you qualify your marksmanship skills by comparing the shot to level fire at that particular range. The quirks of climbing fire are not that interesting. Climbing fire is more schematic than you think. I would say that climbing fire isn't really ideal as much as climbing fire is simply a possibility, and that the only reason why you should train for climbing fire is for completion. Technically, in rheology, due to the quadratic equations, there are usually two possible solutions. This isn't to say that both solutions are even worth anything. The second solution is the hang fire solution, which is similar to firing mortar rounds, where you are looming. You fire the bullet almost straight into the air, and what will happen is that the bullet will fall out of the air almost perpendicularly to the ground, and you would hope that the bullet strikes your opponent on the top of the head. But this pretty much is an autism solution. You should ignore this possibility. It is also possible for climbing fire to be an authentic solution. The bullet is actually increasing in elevation, and this costs a lot of energy to complete. This means that the bullet's path will be curved by all of this energy loss. The final firing mode is plunging fire, and plunging fire is for smart individuals. Plunging fire is the preferred choice, so you should remember this. To fully understand the perks of plunging fire, you should know that the quadratic curve has an apex as a topographical feature of the curve, and that the apex is the most curved part of the curve, and that the curve is approximately flat near the curve's legs. The bullet will accumulate most of its deflection during the apex of its flight, and then it will become approximately straight downwards. When you are firing climbing fire, the apex of the bullet's flight is ahead of the gun. When you are firing plunging fire, the apex of the bullet's flight is behind the gun. Therefore, when the barrel inclination is negative, the bullet's trajectory does not travel through the apex, and the bullet's path will stay relatively straight. If you remember from algebra class, the actual shape of the quadratic curve is added to the initial speed of the bullet while it's traveling out of the barrel. The apex is not located in the center of the graph. The apex is actually shifted horizontally by the barrel vector. You should essentially actually be asking if your bullet has enough horizontal momentum to reach the target. Otherwise, your bullet will land short of the target. The flight time for plunging fire is also decreased because the bullet is not slowed down by gravity. The bullet reaches its target sooner, and the bullet takes a straighter path to get there. This is desirable to the operator because plunging fire is more reliable than climbing fire or even level fire, and plunging fire is considered to be a luxury in marksmanship. You should know that plunging fire becomes increasingly rare at higher altitudes because the shape of the land almost never permits shots that have 60, 80, or 90-degree inclines. You could have a few, but they are increasingly rare. You should spend the majority of your plunging fire training aiming at targets that are 30-degree downward slopes, because this is orthotically fit to what you will experience in the field. Thank you, everybody. This has been Onos again. I wanted to give my 2 cents on the topic. I wrote this essay a while ago, and I wanted to publish it. So thanks. Bye. This is also a non-professional document. Thanks. Bye.